Hey guys, today we're going to use the law of cosines to find sides and angles of triangles. First thing I want you to notice in this law of cosines is that there's two parts. It seems like a giant thing to memorize, but it's not that bad when you break it down. The first part of this version should remind you of something. C squared equals a squared plus b squared. So since you already know the Pythagorean theorem, just remember that. And the second part is the part you'll have to memorize, is 2ab cosine c. Well, because it's law of cosines, it should be pretty easy to remember that you use cosine. And notice that a and b are simply the same values that you had earlier in the equation. So notice that angle c is over here. That's a capital C. Side c, which remember is opposite, is on the opposite side. So yeah, let's do this. So there are other formulations, and I'm going to show another one later, but basically A, B, and C are all interchangeable. The important thing is that these two, whatever you put in here and here, needs to also go here and here, and whatever you plug in for C squared, the side over here, needs to be across from angles C over here. Cool. Alright, so what do you need to know to solve a triangle using the law of cosines? You notice that we have all three sides and one angle in the formula, so you need either all three sides, in which case you'll find an angle, or you need two sides and an angle, and the angle has to be the angle between them, because you always have to be looking for this angle way out here. You can't use these equations to find, well, it wouldn't be easy to find A or B. Yeah, so always looking for two sides and the angle that's between them. So here we would have sides A and B, and the angle between those two is angle C. And I want you to just check out, don't write that down, but try that on your own. What happens if the angle between them is a right angle? Go ahead and sketch that out and calculate that. You might need to do it at the end of the section if you're not sure what I'm talking about. But yeah, just try that on your own and think about what happened and why, and it should start to make sense when you think about it for just a little bit and actually write the math down once. So cool, let's practice doing this. So first off, I'm going to write another formulation. You notice the only thing I switched around, I put B out on the outside, which means angle B is over here, okay, and C and A are there and there next to the cosine. The reason I did that was because angle B is one we know, and it's C and A, which are the adjacent sides, are the sides that we know. You could just rename these if you wanted to call this angle C instead and call this side B to make match the other equation. You could do that, but since they already gave these to us, I figured we'd just use this formulation. Yeah, whichever is easier for you, changing the letters or just switching the formulation around. So let's plug this in. We don't know B. The reason I chose B to be out here is because that's the side we don't know, and you always want to have that be the side you don't know if you don't know a side. So we plugged in A and C in there, and really we just type all of that into a calculator. Make sure you're in your degree mode. You get B squared equals 700. Don't forget that 700 is not B, it's B squared. So we need to do a square root. And so B is actually equal to the square root of 700. However, that can be simplified, so we get B equals 10 root 7, and you're even allowed to type this in the calculator and round it, which would be about 26.46. So let me write that in right there, 10 root 7. In order to find angle A or angle C, since you're always asked to find all the sides and angles in these kinds of problems, or often are, you could use a law of sines, but this actually could apply to the ambiguous case could apply to this, so I would avoid the law of sines, even though it seems simpler than the law of cosines, and let's just learn how to use the law of cosines when you have all the sides and need to find an angle. So what I've done is I've written the formulation the first way we learned it, where C squared is over here, and we actually know A, B, and C. Now we know all three sides. We're looking for angle C right here. And so that's why we just switch that around and not have angle B be out there. Let's plug all these numbers in. Right here I want to pause and show you, let you think about the very next step. Okay, the order of operations says that we need to do addition and subtraction first. So a lot of people go, oh, well, let's add those two together and then subtract that, and then we're good to go. The problem here is that you're multiplying this. People always forget those two are multiplied together. So it's a bit like saying, hey, what if we had 2 plus 3x? Can we just add the 2 and the 3 together? Well, no, you can't, right? You have to do 3 times x separately. That should come first. And so to undo it, if you're in an equation or something, you have to take away the 2 first, subtract the 2. Well, we're doing that exact thing here. We need to remove these guys from the right side and then divide by that guy. And that's what we're going to do, and that's what people always forget and mix up doing. So be on the lookout for that. So we subtract those two from that side, and then the very next step that we'll do is divide by that. I left all this kind of together here. You could at any point plug any of these into a calculator. I'll just plug them in right now, and I rounded it to get 0.7559 equals cosine C. The later you type it in the calculator, the better. In fact, you could type this whole thing with inverse cosine in the calculator. That would be the best. But I'll just show you what I did. So by doing inverse cosine of both sides, you do inverse cosine of 0.7559 is equal to C, and we get that is about 40.89 degrees. All right. So let me go ahead and label that in the triangle. We could go ahead and do law of cosines all over again, but we already know that those 3 triangles have to add up to 180. So I feel perfectly fine saying 180 minus those 2 and getting 79.11. And you should be fine doing that too. Okay. So try this one. Pause the video. Try this equation now. This triangle. Find angles A and C and side B. And I'd recommend finding side B first to help you out with that. Okay. Once you finish with that, and you can pause the video now, but once you're done with that, I want to show you how to do this next one. This will be another traditional formulation where they gave us all 3 sides and we need to find an angle. Here we actually can't use the law of sines, so we're going to use law of cosines again because we have all 3 sides. It doesn't matter which angle you put out here as long as it's the same or across from the side that's over here. So we're just going to find angle C first. Let's plug in all the values. Again, be very, very careful. I'm going to write these out. Be very careful that you don't just take 36 and add 49 and subtract 108. Remember, because this 108 is being multiplied to the cosine. So it goes with the cosine. We've got to subtract these over here first, like that, the 36 and the 49. And we'll now divide by 108, or negative 108. And when you type that in the calculator, you get approximately 0.6389. By using inverse cosine, you get the angle, which is 50.29 approximately. Okay, so I'm going to pause here and let you find the other 2 angles, B and A. Feel free to try to use law of sines, but you'll see from when we talk about the ambiguous case why that can be problematic and might be more of a headache than simply doing law of cosines. So go ahead, find angles A and B. Lastly, I need you to find all 3 angles. Make sure you do all these before coming to class, and we will do all of that and more practice later. Hope you learned something, and thank you for watching.